In this video, I will show you how to find the velocity when derivatives are involved. Let's start with this example. A ball is dropped off from the Burj Al Arab building at t equals 3 seconds. The equation s of t is equals to negative 12t squared plus 300 models the position of the ball, where s is in meters and t is in seconds. What is the instantaneous velocity when the ball hits the ground? The first step that we need to do is rewrite our equation given, which is this. S of t is equals to negative 12 t to the power of 2 plus 300. Now, in order to rewrite this equation, we need to find the derivative of each term. They wanted the velocity, so v of t is equals to derivative of s of t. Now, in order to find the derivative of the first term, we need to multiply negative 12 by the power of t, which is 2, so it will give us a product of negative 24 t. And then we need to subtract the power of t, which is 2 minus 1, equals to 1, which we don't have to write it, plus 300. The second term is a constant number with no letters, so this is simply equals to 0, which we also no need to write it in the equation. Now they wanted the velocity at t equals 3 seconds. We're just going to plug in 3 by t. So v3 equals to s derivative. And then we're going to plug in 3 by t. So when we have a bracket near a number, that means it's multiplication. So negative 24 times 3 is equals to negative 72 meter per second. Now let's move on to the second example. A diver decided to go on a hunt for some pearls during the National Day. At t equals 6 minutes, the diver jumps from a platform above the water. The position of the diver is represented as s of t equals 7t cubed plus 30t, where s is in meters and t is in minutes. What is the instantaneous velocity of the diver? Now, as we did in the first example, we're going to rewrite our equation, which is s of t equals to 7 t to the power of 3 plus 30t. And as you can tell that it needs velocity, the question wants the velocity, so v of t is equals to s derivative of st, and we need to find the derivatives of the two terms given in the equation. So 7 times the power of t, which is 3, is going to give us a product of 21t. And as we did again on the first example, we're going to subtract 1 from the power of t, so 3 minus 1 is 2, plus 30 times the power of t is 1, so 30. And now it wants the velocity at t equals 6 minutes. So we're just going to simply plug in t with 6, so 21, 6 to the power of 2 plus 30 equals to 21 times 6 to the power of 2 will give us product of 36 plus 30. And if you plug in all of these numbers in the calculator, it will give you a total of 786 meter per minute. And now let's take our last example of velocity with derivatives. An airplane is flying towards the UAE from Europe along a constant flight path. The position of the plane, which is measured in kilometers, is given by the equation s of t equals to 2t squared plus 80t. When does the velocity equals to 200 km per hour? Now in this equation, it's different than the two examples that we did earlier. Here they want the time instead of the velocity. So let's start by rewriting our equation, which is s of t equals to 2t squared plus 80t. Now in order to find the time, we need to find the velocity first. So v of t equals to derivative of s of t, which is equals to 2 times the power of t. So 2 times 2 is 4, and then we're going to minus product from the power of t, so 2 minus 1 is equals to 1, which we don't need to write, plus 80 times 1, which is 80, and this is how we rewrite our equation. And now we need to find the time. So 200 kilometers per hour is the velocity, so we're going to write 200 equals 4t plus 80. Now in order to find the time, we just need to let the time on one side. So minus 80, it will give us a product of 120, which is equals to 4t, and then we're going to divide both sides by 4, which will give us a product of t equals 30 hours. And that's it. Now that I've shown you on how to find velocity when derivatives are involved, I'm going to show you how to find the acceleration as well. At the opening of Expo 2020, they were shooting fireworks. What is the instantaneous acceleration at time t equals 8 minutes of the fireworks, whose position equation is represented as s of t equals 6t cubed minus 42t squared plus 12, where s is in meters and t is in minutes. Now in order to find the acceleration, we need to rewrite our equation first. So s of t is equals to 6t cubed minus 42t squared plus 12. We need to find the velocity first, then we can find the acceleration. So v of t is equals to the derivative of s of t, which is equals to 6 times the power of t, which is 3, will give us a product of 18t. Then we're going to minus product from the power of t, so 3 minus 1 is 2, minus 42 times 2 will give us product of 84t, and 2 minus 1 is 1, which we don't need to write. And as I said before, when you see a constant number, it means it's equals to 0. And now we can find the acceleration. So a is equals to the derivative of v of t, which is equals to, we're going to find the derivative from the equation that we rewrote earlier. So 18 times 2 is equals to 36t. 2 minus 1 is 1, which you don't need to write again, minus 84. And now we need to find the acceleration. So equals to 36 times 8. We're just going to substitute 8 instead of t, minus 84, which if you plug in this all in the calculator, it will give you 204 meter per minute. Finally, let's move on to our last example. The position equation of a moving robot in Expo 2020 is given by f of t equals 9t to the power 4 plus 2t squared. Find its acceleration when t equals 3 hours, where f is in meters and t is in hours. As we did in our previous examples, we're going to rewrite our equation. So f of t is equals to 9t t to the power 4 plus 2t squared. At first we need to find the velocity. So v of t is equals to the derivative of f of t. Now in order to find the derivative, we're going to multiply 9 times the power of t, which is 4, giving a product of 36t, and then 4 minus 1 is 3, plus 2 to the power 2 times 2 is equals to 4, and then 2 minus 1 is equals to 1, which we don't need to write. And now we need to find the derivative of v of t for the acceleration. So acceleration is equals to derivative of v of t. So a t is equals to 36 times 3 will give us a product of 108 t. Now 3 minus 1 is 2, plus 4 times 1 is 4. And now we just need to plug in t equals to 3 hours and substitute it in t. So A3 is equals to 108 times 3 to the power of 2 plus 4, which will give us a total of 976 meter per hour. And that's it.